Okay, so here we have the atom of oxygen. And so here's my little graph. And normally, for the actual atom, the nucleus would be in the center and all the levels would be around it. But this is just for showing you guys and like graphing it out. This is why it just all moved to the side to where we can see everything, including the protons, electrons, and the neutrons, alright? And including the levels as well. Alright, so first, the actual element and like how it has the protons and the electrons. Its the number of protons it has is 8, and the average atomic mass is 15.999, or also known as AAM. And so what you do to find how many neutrons it has is that you take the AAM, which is 15.999, and you round that up to 16, and then you take the protons, which here is 8. You take the protons, which is 8, and then the formula is the atomic average mass minus protons equals n, which is the neutrons, which is what we're trying to find. So then you would take the AAM, which is 16 now, and the protons, which is 8, and you do 16 minus 8, which you get 8. And so that gives you 8 as the neutrons. Alright, and then there I have put it clearly in the nucleus, the 8 protons and the 8 nucleuses. And now, since the protons they're a positive charge and the electrons are a negative charge, that is why electrons are the exact same number of protons, because they have to cancel out. So 8 minus 8 is 0. So then it's a 0, it's balanced. So then since there's 8 protons, you would have then 8 electrons. And since there's a little pattern with the levels here, first level can only hold 2 electrons, the second can only hold 8, third can only hold 8, and the fourth can only hold 2, alright? So that's the pattern. And so here, since I have 8 electrons, I need to distribute them amongst the 4 levels I have. And so since I can only fit 2, 2 is the maximum I can fit on the first level, I can only fit 2 on that one. And so then I put the remaining amount of electrons, which is 8, on the next level. And the remaining amount I have 6. But I'm allowed to put it on this level because 8 is the max, and I have gone underneath the limit. And so I have 2 here and 6 here, alright? Which is 8. Now, to take a step further, just to tell you guys, if a level isn't... See, now this level here is very stable because it's full to its mass. It's very solid and stable. This level here, the third level, right here, is also stable because it has none on it, so it's like a solid form. But this level in the middle here, the second level, which can hold 8, but it's only holding 6, is not stable at all because it has more of a structure that is needed to be filled in, such as with the 8 here, but we only have 6, so it is not very stable. And so either an element is empty, it is stable, or it is completely full to its max, is stable. But if it's not, then it's not stable at all. Alright, and if this happens, the atom automatically wants to get more electrons or lose the electrons for this level to be able to have the full atom stable. And so now, what is easier? Is it easier to completely take away 6 electrons, or is it easier to gain 2? Either take away 6 or gain 2. Alright, well the answer is to gain 2 because there's just less you have to gain. And so this atom will automatically, once oxygen is formed, it feels that it is unstable, so it will gain 2 more electrons from another element, and then choose that. And so then you would have 8 minus 10, because from the 8 minus 8, which is 0, to make the atom balanced and everything. Well, now it's going to be 8 minus 10 because you just gained 2 more electrons to the atom. And so, from this oxygen atom here, it would then turn into, instead of looking like this here, the oxygen equals 0, 0 as its symbol, this symbol would then be this, because you have to show that it has the negative 2 because you just added more electrons. So yeah, that is my graph for the oxygen turning into oxygen -2 charge. Thank you.